everybody. I can see there's already about 100 or so people queuing up to get in the doors tonight. Welcome to week 3 of Big Data. My name is Shane Murphy from IT Masters, and we're doing week 3, which is Applied Big Data Analytics and Cybersecurity Management with Matt Constable and Lil. Newen will be joining us as well to be doing all of our moderation in the chat room. Remember, everybody, to turn your chat to everyone because it defaults to something else when you start off. And why don't you say hello in the chat and let us know where you're from, what the weather's like in sunny Melbourne. It's actually been warm today, which is lovely. And as always, we will give it about 3 to 4 more minutes to allow everybody to get settled before we invite Matt in and start properly. But good evening, everybody, and I hope you've all had a lovely day and are staying safe. We'll speak again in a couple of minutes. So I think just about most people are here now, and so formally let's kick things off. I'd like to welcome you all to Big Data Week 3, Applied Data Analytics in Cybersecurity Management. As always, and just remind everybody to put your questions that you would like Matt to answer in the Q&A, and to just keep chatting amongst yourselves and with Lil in the chat. It's where actually a lot of the good information comes out because other people are very knowledgeable often about the stuff we're talking about, and lots of good interchange happens in the chat. So please keep an eye on the chat. I can see, as I said before, we've got people from all over. We would prefer just to let everybody know that not put your LinkedIn and everything up there. You can do that in the forums preferably, but in the chat during the webinar, let's keep all of that sort of stuff out of it. It is a very good chat situation, and we like to keep it that way. So yeah, as I said, questions only in the Q&A. They're the ones we will answer live with Matt. We hope that you enjoy this evening. It is week 3, and with no further ado, I'm going to turn it over to you, Matt. How are you this evening?
Very well, thank you, Shane, and welcome to everyone this evening for the 3rd installment of our Big Data online course. It's lovely to see so many visitors from all over the planet. It constantly amazes me each week, the range of people we have from different places in the world. It's just such a change from when I first started teaching in a classroom as a tertiary level educator so many years ago, and you only had to talk to the faces in the room, and now we have a global audience. So it's fantastic that we're in this position to be able to share our knowledge with all our friends from wherever you happen to be coming from. So welcome, everyone. So in the first couple of weeks of this particular course, we've looked at the basic concepts around big data, what it is, the components that make up the infrastructure or the architecture, if you like. And now we're going to turn in this week to looking at a general overview of a specific application of using big data and the analytics associated with it for a particular purpose, in this case, cybersecurity management. And then next week, we're going to look at some of the challenges around the 4 or 6, arguably, V's that we've sort of alluded to in the first week, and we'll talk a little bit about them again tonight. And so after that, you should have a really nice rounded idea of all facets of big data at that high level, and particularly around this specific implementation of it. So let's have a look at what is on the agenda for this evening. We're going to look at the importance of cybersecurity in the digital age, and I don't think any of certainly, I don't think any of you out there, and certainly no one at IT Masters or any of the other places I've ever worked, have doubted the importance of cybersecurity. As we progress more to this online world that we're in, and let's face it, as you know, recent things with CrowdStrike and some of the other cyber security attacks with Medibank and Latitude and Dell and these sort of places that have happened around the place, we know now that you know we're so reliant on our digital technologies and the internet and these interconnections of networks that we have on the planet to pretty much facilitate everything within our life, all the way from our food supply chain to manufacturing to health and healthcare to our, and certainly our entertainment. There's lots of that, lots of sort of applications in that sort of perspective. You know, there's just so much involved and so much that we rely on these online systems. And of course, that also opens up a vast array of opportunities for hackers, attackers, criminals of various types and ideologies and motivations to attack us from different angles and therefore create havoc in some parts of our lives, or create really bad, serious outages that can really impact the way in which we live. We're really fortunate that at this stage, we haven't had too many that have really focused on critical infrastructure. So power being a perfect example of that, electricity that is. But it's only a matter of time before the evolution of the online environment starts to, be ingrained more in those sorts of areas, and then the opportunities are going to arise for attackers. And of course, because off the back of that, we need to ensure that our cybersecurity systems are as robust and resilient as we can possibly make them, and that we're providing our customers, clients, users, workers with their systems when they need them, and the information they need at that time as well. There are, of course, many different ways we can be attacked. Online systems can be attacked, and these are known as threat vectors. So a threat vector is a potential way in which you might be attacked. There are, of course, now a lot of different threat actors as well. So these are the different types of groups of people that would attack you, from criminals through to simple script kiddies, or people who are just trying to learn about security and just trying to make a nuisance of themselves. We've got hacktivist type groups like Anonymous is probably the most famous one. We have state-sponsored threats, so government agencies are doing this sort of thing as well. So there's lots of that. We've got industrial espionage. There's just so many different avenues for us to be attacked. So we have to make sure that cybersecurity systems are up to date. Now, cybersecurity is very much a reactive type industry, right? So yes, we have a lot of different ways and systems in which we can protect our digital assets, but at the same time, it's also true that as we are evolving our mitigation techniques and our defensive capabilities, those who would attack us are also evolving and becoming more sophisticated, more advanced, leading to this idea of almost like an arms race between the good and the bad. And so, a lot of what we implement in cybersecurity, even though it's built on foundational, well-known principles and evidence, there are still going to be things that crop up pretty regularly, and more regularly than what a lot of people think, that result in us being attacked via a new way or from a new avenue. And we have to be quick to respond to that. And this is where big data starts to come in terms of our cybersecurity analytics. So it gives us the benefit and the opportunity to take in all the vast amount of data that we have from logging around our security-based systems and sifting through that in a really quick, efficient, and intelligent way. So the characteristics of big data, which we'll look at, which are also form some of the challenges as well, And we've sort of briefly mentioned them in week one, and we'll look at them again from a challenge perspective next week. But volume, velocity, variety, and veracity, in particular, volume and velocity, are really key benefits of big data that can help with cybersecurity. We get a load of information, lots and lots and lots of information from our different monitoring systems and the different systems that are designed to help protect our digital environments. And it comes in at great speed. And so because it's delivered to us in large amounts and quickly, it gives us the ability to then interrogate it, intelligently analyze it through the use of sophisticated search systems, and therefore allows us to be very agile in our response to cybersecurity incidents. We can integrate big data analytics into our real-time monitoring, our threat intelligence in particular, are really important ways we can implement it, and also in things like, dare I say, CrowdStrike. It's probably not the best word to say at the moment, but in those types of vendors that offer enhanced detection and response and managed detection and response solutions, because that's basically what we give them. We take a little agent, like what caused a lot of problems the other week for CrowdStrike, and we install it on our devices that we want to be protected. And those devices send out volumes and volumes of telemetry and log data back to CrowdStrike, who then put that into their big data systems, so their data warehouses and their data lakes, and then they use their search tools and AI analytic tools to be able to search through all of that to determine when things are going wrong. And because we have such huge amounts of data that we send to them by these agents, and it gets to them in almost real time, it allows them, through the use of their sophisticated tools, to identify when things go wrong very quickly and therefore be on the front foot in terms of responding. So big data cybersecurity is important to combat not only current day threats, but things that might turn into threats or things that are evolving. So think cutting edge sort of attacks and attack vectors and maybe new attack actors in the future. Clearly, what we want to do is prevent unauthorized access from the get-go. So stop people from getting into our systems before they gain a foothold and can then leverage through the use of lateral movement to get into our system and then escalate privileges and so on and so forth. But on top of that, if we can't, for whatever reason, prevent them from getting in, we at least want to be able to prevent their presence very quickly and be able to knock them out and get rid of them from our system as quickly as possible. I think I said last week in our class, or maybe I'm thinking of something else. But anyway, there was an IBM report that came out not that long ago. And apologies, I can't remember the exact numbers, but it was something along the lines of incursions are not generally noticed in digital systems until many, many hundreds of days after those systems have already been compromised. And then on top of that, it takes an extra, I think it was 70 odd days on average to remediate and remove. So we're talking, almost 9 months from when someone gets into your system to when they're out of your system. And that's, you've got to take that with a grain of salt. You've got to interpret that intelligently. So that's an average over all of the surveyed companies who responded to that particular survey. So does that mean it's captured every single piece of possible information out there about incursions? Absolutely not. But that's a data set we've got to go on. The framework of big data allows us to adopt machine learning and AI, so overlay that over the top, and therefore allows us to very quickly search through this vast amount of data and narrow our focus down to specific suspicious activities or known heuristics of suspicious activities or attacks. Of course, we want that to be as real time as we can possibly get. Now, there's always going to be some form of latency involved. Okay, we can't transmit data across the internet to a repository somewhere and have it searched and immediately flag someone at the exact moment it happens. There's always going to be some latency, but with the way digital systems are now, that is relatively small, and we're talking in a matter of milliseconds in most circumstances. Certainly with the information I've seen from CrowdStrike when their system's working. Well, obviously, but as close to real time. So we say real time analysis, but it's not really real time, but it's very close to. I'd call it more near time analysis. Of course, we want to be able to specifically identify types of attacks and actors if we possibly can. If we can understand who the threat actor is, based on what previous knowledge we have about that threat actor, we have a better understanding of what attack vectors they might be using, even if we haven't got to the point where we have specifically identified the type of attack. So it helps to narrow things down. And all of this crucial information is provided by these volumes of data that is coming in from multiple customers and multiple systems. If we're talking about someone like CrowdStrike or Sophos that offer these sort of XDR, MDR, EDR type systems. If we're talking about internally, it still helps because we're pulling in all this information from our own systems. And when things are good, we're building up an understanding of what our baseline activity is and what the baseline behavior is on our digital systems. When something starts to deviate from that, even by a small amount, we will be able to detect that through the use of our big data analytics. So it helps us to keep our infrastructure, our digital infrastructure, secure from old threats or well-known threats, which there's plenty of attacks that have been around for many years and are still being used today. The main reason for that really is because, as I guess as an industry, maybe not as a cybersecurity industry, but a lot of places simply haven't learned. They haven't learned lessons from things that have happened, incidents in the past. And so vulnerabilities and problems and bad habits are still there in the IT services industry. And so these old attacks that have been around forever still work on certain targets in certain places. And so that's something as an industry we have to address separately, obviously. But also this big data analytics and analysis of all this huge amount of information we have gives us the ability or enhances our ability, if you like, to detect new and evolving threats. It's not very often something will come along that is completely and utterly new. The vast majority of times, new attacks will be variations of previous attacks. So small changes, not massive holistic changes. And so that, in a way, is a little bit of an advantage to us on the good side of the ledger, if you like. So that means it helps us to identify these zero-day attacks. So a zero-day attack is simply one that has never been seen before. This is a 0 day that it has appeared. If attacks were completely brand new and they'd never been seen before and they're not associated with any other type of vector, they're not associated, they don't exhibit the same sort of behavior as anything previously, clearly they're going to be more difficult to detect and respond to. But because that's not the case, as I said before, this analysis using these big data analytics helps us to be able to identify these new, so to speak, attacks as they come along. Insider attacks are also a big problem as well. And this is because of the elevated privilege, if you like, that people inside our network naturally have. I mean, of course they do, because they need to use our systems in a way that allows them to deliver the outcomes required for their job role. If we make it too hard for them to do that, then our business productivity starts to drop off and things don't work the way they should do. So because inside users have elevated privileges, chances are they can also attack a lot easier should they become disgruntled, bought out by an intellectual competitor, perhaps, or for some of whatever reason, a myriad of reasons, they might determine to attack from the inside. Malware, of course, and viruses, other sorts, and ransomware, other things that come into our system and effectively launch an attack from the inside. So they come in via some sort of harmless or seemingly harmless distribution method, and then they get released from the inside. So we've also got to think of it from that perspective. And some of those, particularly like ransomware, once it gets a foothold in your network, the only real way out is to restore via a full backup or rebuild. Unless you want to pay, unless you want to take the risk of paying the ransom and maybe not getting the decryption keys anyway. The whole thing is about ransomware is because, of course, that it's based on encryption. Modern encryption protocols are feasibly impossible to, computationally infeasible. That's what I was trying to get at. Computationally infeasible to break. While that's an advantage for us when we use it to protect our information, it's also a huge disadvantage when someone gets into our system using ransomware. We don't have the capabilities to really break even low-level type AES or RSA encryption at the moment. People talk about quantum computing, being able to break it, RSA in a very short period of time. Those quantum computers are still a way in the future, okay? So it's not going to happen. So ransomware, to get over that, you really need to be able to have a full backup to do a restore or rebuild. Big data, however, using analytics can help us to detect it before it takes a really big foothold in our network. Okay, so if one or two hosts are overwhelmed with it, that's okay. We can shut it down, we can isolate it, we can sandbox it. After that, once it gets into our entire system, it becomes obviously impossible to do that. We can also use it for network monitoring, for implementation around cloud environments, specifically for endpoint security. So when I say endpoint, I'm not talking about servers so much now, but I'm talking about desktops, laptops. So those devices that are providing utility of the digital systems to our end users. And clearly threat detection is also very high on the cybersecurity agenda as well. So having said that, let's look at it in more detail. So we're mainly talking about NDR and EDR. So network detection and response and enhanced detection and response capabilities and managed detection and response capabilities. So this is where we outsource. Typically, in most cases, this is outsourced. We outsource this ability to another company like Sophos or CrowdStrike. We install a little bit of agent software on our devices that we wish to protect. And then those devices spend well, not all their time literally, but they spend lots of time sending information about what's happening on that particular system, what's happening on the network, who's coming in and out of it, what they're doing, all the way from simply traffic entering it, flowing across the network, all the way down to users authenticating what files they're accessing, how they're accessing them, so on and so forth. So all aspects of what's happening on a system are logged and sent via this agent to our security vendor, whoever that is, Sophos, CrowdStrike, whoever. And then they use machine learning and artificial intelligence to identify patterns and anomalies. They use behavioral analytics and they use that in an active sense. So they've literally got people watching screens in the here and now. So the AI, machine learning and AI part of it, right? So what that does is that sifts through the data as it comes in from each customer, and it identifies things that are anomalous to baseline. It then passes that over to the human users or other systems, which then start to perform behavioral analytics and start to actually look at things with their eyes and interpret it from it. So you've got expert humans looking at it and interpreting it from a human point of view with a human level intelligence. Okay. Artificial intelligence, yes, it's here to stay, it's getting better, it's getting faster, but really, at the moment, all it really is a glorified search engine in most cases. We still need someone who is experienced and knowledgeable to be able to sit there and sift through things that are raised as potential problems and make a final decision on them. Otherwise, we can get more false positives or false negatives, even worse, that is simply going to not provide us with a whole lot of benefit. So we need to be able to use it intelligently. NDR tools use non-signature based advanced and analytical techniques. Okay, so we use machine learning to detect suspicious network activity. Okay, now the important thing that we must have before this really works is we must have an understanding of what is normal behavior on our systems. So if you were to say go and purchase this sort of product from CrowdStrike and you were already compromised in some way, and you started to build a baseline on your compromised system, then your baseline would be faulty. And so it would be more difficult to detect certain anomalies or certain types of attacks. So the baseline needs to be a really thorough and well understood, valid measure of what is happening under normal circumstances, normal permitted circumstances in whatever digital systems or parts of your network that you're actually protecting. It's so important to have that solid baseline because without it, without knowing what is normal, you can't detect what is abnormal. Now, these systems, once you've got that baseline and you've got the agents set up and they're sending all this information back to these machine learning and AI systems, they are continuously analyzing everything as it comes in. So basically the raw network packets and the information contained within that and the information about them. And this includes between internal networks, which is classified as being east-west. So you're moving laterally inside your own network, which is what attackers like to do as well. And north-south refers to from access to your internal networks from public networks. So most typically the internet, or that's the one we usually think of, but it might also be extranet partners as well. So north-south is the outside coming in, east-west is laterally moving from subnet to subnet or host to host, for example, within your actual network. And both of those are important to monitor because it may be that you don't detect someone when they're coming in via the north-south direction. But once they get in, it's very unlikely that they will stay on a single compromised system, but they will try to laterally move. So they will try to move in an east-west direction to gain a foothold in multiple systems, which then makes them more difficult to remove. And also to detect in a way because they can spread operations, whatever they're doing, across multiple machines and maybe not trip over specific alarms or thresholds that you have in place. So it's a very interesting and very profitable way of working through a network in that east-west direction for attackers. Machine learning and AI software, when trained, machine learning in particular, when trained properly, is excellent at being able to provide you with very realistic and very real-time threat detection and allows us to predict and detect these ground zero type attacks simply by evaluating the information that we provide them with, which allows them to view or gain an understanding of all the different possible vulnerability points that we have inside our network. And of course, a vulnerability point is a way in which is a portal, if you like, or a door through which an attacker can enter our network. Endpoint detection and response, of course, is where most of our data is either generated or pushed to. So we're talking about desktops, handheld devices, anything you can think of. Even servers, we can consider them as endpoints as well. Anything that allows network traffic to transit through it is not it's an infrastructure type device, but pretty much anything else that's connected or related to a user or a customer is an endpoint. So as you can imagine, we have literally billions of endpoints on the planet connected to thousands of different networks, that in itself represents a huge risk. So if you think of something like, let's say you have an iPhone and you've got 10 apps on it, those 10 apps will connect to potentially 10 different systems. There's a portal. Okay, there's a portal into those 10 different systems. Now, yes, the security around apps, both at Android and iOS level, is very stringent, very strict, but it's an opportunity. It's definitely an opportunity. And that's just talking about one simple device, let alone all the other devices we have at our disposal. And so these endpoints is one of the most vulnerable areas of a network. Yeah, so if someone can get access to your endpoints, so a typical example, which I've seen happen many times, is a remote worker with a laptop will go to a cafe or a restaurant, let's say a Golden Arches restaurant, something like that, and they'll sit down, they'll connect to the public Wi-Fi, and they will connect to their work network via a VPN, which may or may not be adequately secured. Of course, their device can be seen by anyone who's around them. There's a potential for compromisation and then jumping into the work network from that particular point. That's with one laptop. That's with one handheld device. As I said before, there are billions of them floating around the planet. The opportunities for attackers are endless. So there's a lot of work we need to do in the cybersecurity industry to keep ahead of that, obviously. And that's a discussion for another day, another subject, another time. But in terms of how does big data help us with that? Again, just through the analytics. So searching through the raw data that we provide it with and finding patterns, finding anomalies, raising them as alerts and allowing us to intelligently interpret them. As it says here, the global endpoint security market was almost 13.4 billion US in 2023. And to be frank, to be really honest, that to me seems low. It seems low. What I mean by seems low, it may well be an accurate figure, but I think it should be more than that. I don't know about you people out there listening, but I know from my own personal experiences across a range of different industries and a lot of different employers and people that I've worked either as a staff member for or contracting in or integrator or consultant over the last 30 years. Cybersecurity, although it's getting understood now and more attention is being paid to it now. But cybersecurity has been one of the most underrated avenues for spending money in the history of IT. In fact, the two industries that I've spent most of my life working in, networking and cybersecurity, are probably very heavily, arguably, the two most important IT segments ever. Turn off networks, turn off all the Cisco routers, for example, turn off all your firewalls, turn off all your switches. What do you got left? Not a whole lot. You haven't got a lot of access. Cybersecurity, people break into your system, steal your information, corrupt your information, put some ransomware on, hold you to blackmail. Okay, you've got nothing. Nothing at all. So while all the other areas, certainly, look, I'm not trying to denigrate any of the other areas in IT. Everything is valuable. We work together as a group, as a team to provide magnificent solutions. But cybersecurity, underrated. Still, I think even in this day and age, when it's very well known how important it is. And part of that, I think, is because of this because of the fact that we don't have, or a lot of places don't have the visibility into what's really happening on their network, and they're lulled into a false sense of security. Big data analytics, that will help you solve that problem. You will always know as well as you possibly can what's going on in your network, what's good and bad. Yeah. So this part of big data, this implementation of big data is just massively important and will only become more important as the passage of time passes. So EDR platforms scan all incoming and outgoing traffic for specific types of data. And this includes all processes running on a system, all the files that exist on a system, so system and user files, all the different connections that are coming in, all the different users that are associated or active on that particular system, and all the other bits of bits and software bits and pieces that might be connected to that system or facilitating access to that system, like switches and routers, for example. So EDR will then focus on three stages: pre-attack, which is the idea of using our big data analytics to search through all of this vast amount of information that we're getting, to identify what might be going on and to prevent things, okay, before they get too bad. So we're talking about things like endpoint discovery, so discovering new devices when they come on and become active. Endpoint management. Okay, unified endpoint management just means we look at them as a single collective group or divide them into certain categories. Vulnerability and patch management, massive, absolutely massive in cybersecurity. Big data analytics helps us to determine what stage we're at right across all of our digital systems, because that can often be in big organizations, that can be a really hard thing to keep track of. And of course, configuration and baseline checking. So again, there's that concept of baseline. So important to have an understanding of what's normal on your network so that you are able to detect when things aren't going quite so right, when there's abnormalities. Configuration issues, even in this day and age, with all the information we know about how to properly secure systems and harden them, configuration errors still occur. We talk about bespoke software development. There is lots and lots and lots of literature and understanding in the programming industry on how to do things securely, and yet things are still done insecurely. Now, this will always happen. This will always happen. We think it shouldn't, but it will always happen. Big data will help us to determine or identify when these bad things happen. Really, really important. During an attack, it allows us to detect what really is going on. So helping us to identify the type of attack. So yes, initially we might say, hey, there's some sort of attack happening, but we don't know what that attack is just yet. So we need a bit more information to be able to sort through and come up with a hypothesis of what's going on. Big data helps us to do that quickly and efficiently. We can do it based on signatures. We can do it based on behavioral characteristics of known attacks. We can use AI and machine learning. We can sandbox off particular parts of the information that we're analyzing to be able to come to a more tightly evidence-based hypothesis. The active protection type mechanisms that we can implement off the back of our big data analytics include things like microsegmentation. So cutting our network into smaller bits, if you like, to prevent this east-west movement that I was talking about before. We can use tools like ransomware honeypots. Okay, so a honeypot is simply a device that looks legitimate to an attacker, but it in fact has got no useful information on it from an attacker's perspective at all. But it sits out in a part of our network that is relatively unprotected. And so think of it this way: it is like an easy target. And most of the time, attackers will take the path of least resistance. So if you provide them with an easy target, they're more likely, in many cases, not all, but in many cases, they're more likely to go for that target first, which then gives you time for that false target to collate and send data to your big data analytic engine, which then can identify something's going on and allow you to activate some other remediation mechanisms which will protect your other legitimate systems. So the honeypot almost becomes an early warning system from that perspective. Of course, we can use multi-factor authentication as well to help prevent people getting in through those easy authentication methods that are often implemented. Also helps to really defeat things like brute force attacks and enables us to detect them quite quickly. because a brute force attack is just about trying different credentials over and over and over again until we break into a system. Multi-factor authentication helps to remediate against that. It's not to say that you can't do MFA bombing. That can absolutely be a thing that can work in some implementations, but it's better than having a username and password only. And then after our attacks or post attacks, it helps us to look at the residue left by these attacks. So residual threat detection, and allows us to perform forensic analysis to build up an understanding of, okay, what went wrong? We thought we were protected. We obviously weren't. What went wrong? How can we make it better? And all of this incorporates the different elements of threat hunting, threat correlation, and visualization. So putting those three components together to give us a picture of what happened, how did it happen, or why did it happen, how long did it happen for, and how can we stop it from happening again? Real-time monitoring. Okay. Is there any questions you want answered at the moment, Shane, or are we good at the moment?
There's a build-up of questions, so maybe we could go through them. What challenges are faced when integrating big data analytics into an existing cybersecurity framework?
Okay, so that one will be answered in depth next week. So I might leave that one till next week.
Great. What are the best practices for processing and storing large data sets in a secure manner? I think we've sort of maybe gone towards that already.
Yeah, we sort of looked at that a little bit already, but and again, this will be that's another one of the challenges which we'll look at in more depth last week. But just to quickly give you a bit of an answer on that is that don't think that just because we've got these massive data sets that the ways and means that we protect them is any different from what we'd have if we had a very small data set. So the same security implementations are still relevant. It's just that instead of now having small storage a small storage center that we have to protect, it's now a really big one. But the overall principles and concepts are still exactly the same.
Okay. Somebody's still not quite sure about the difference between NDR because it looks like both scan the network.
NDR compared to what? EDR?
Yeah.
Yeah, so NDR is network. Okay. EDR is endpoint. So they're both used together, and often they're combined together under MDR, which is managed detection and response, or XDR, which is XDR, which is, I think it's will depend on the vendor, but the vendor I'm thinking of calls it extra detection and response. So it's just a way of saying that NDR primarily focuses on infrastructure devices and traffic flowing across the network. EDR looks at the types of attacks and information related to someone who's got access to an endpoint and is trying to do something. So they're really one's across the network, one's in and on the device.
And there was another NDR. In what ways does NDR improve the visibility of network traffic compared to a traditional intrusion detection system?
Well, it provides it provides additional benefit simply because our current intrusion detection systems will, depending on how they're deployed, will either, while they will look at network traffic. So if think of it as if you have network intrusion detection system, because there's two ways in which you can deploy, right? Two typical deployment ways: network intrusion detection systems or host intrusion detection systems. Network intrusion detection systems look at traffic flowing across the network. So there's the NDR component of it. Host intrusion detection systems look at the individual endpoint. So there's an EDR perspective of it. The problem is with those is not often do we have the capability of sending all the different information from both of those types of devices to a single repository to then quickly be able to go through it without the help of using this big data architecture. So while the advantage is you get better a better interrogation of the information that you had at hand in a more timely manner, and it's more efficiently digested and got to you quicker than you would using traditional based systems. So speed, efficiency, quality. Simple answer.
Excellent. I'll only do a couple more. Previously, we discussed three states of data, i.e. at rest, in motion, and in use. Of these, is it fair to say that when it's in use, that's most vulnerable, and where the most amount of big data is generated from monitoring analysis to look for unusual behavior and stop it? That may not have read that well. I think the question is it most vulnerable when in use? And how's the best way of stopping it? How do you look for unusual behavior?
Oh, in terms of your data, no, I wouldn't necessarily say it was in most danger when it was in use. I would say it's most danger when it's at rest, when it's being stored. So there's three components of that. There's in rest, so in storage, in transit across your network, and then in use when it's actually within a compute system being open and processed. So that compute, that in use is really about inside processes, inside memory space.
Right.
I would generally say that the data is tends to be more vulnerable when it's actually at storage, because it's less likely that or it's less likely that um, immediate monitoring will be performed in those particular storage spaces. So it gives attackers a little bit more time to um, be creative, I guess is what I'd say to that. And what was the second part of that question? Sorry.
That I think you basically answered that question.
Yeah, so I think at rest is the biggest danger point. Yeah.
EDR post-attack, inverted commas. In your experience, how effective are these tools? What information can be used for forensic analysis from the EDR solution?
Uh, any of the information that it gathers, because remember it's gathering all sorts of information about alerts, logs. I mean, every single piece of information that an EDR system receives is of potential value depending on what the type of attack is and what's going on. Yes, sure, some of the log messages will be completely normal and expected, but others will be quite obviously anomalous. And then there'll still be other things that might not necessarily point to something bad happening, but they will give you a clue to something else has happened, and then you look at that, whatever that something else is, and that leads you further down the path. So it becomes if you like, you think of a trail of breadcrumbs. That's basically what it becomes. So any evidence, any sort of data that's kept by an EDR system has the potential to be used as evidence and have some sort of evidentiary value in not only pointing to who's been into your system and what they've done, but how they got in the first place. And of course, that's really valuable because then you can then use that information to go back and patch those holes, those security holes that allowed them in the first place. Actually, I remember the other thing I wanted to say about that previous answer was that there was a hinting something about the baseline there. How do you know? Um, and this is why baselining is so incredibly important to understand what is normal everyday, regular, expected behavior across your network before you can determine what is anomalous. So, and this has to be done, this baseline recording and analysis has to be done over a period of time. So it has to be done over a sufficient period of time such that it captures all the different processes you might perform in a given time period. So say, for example, you took a baseline of your network for a week, and that's all you looked at. You took a week's worth of traffic, you looked at it all, you said no, no, and you could tick and cross off everything. You could account for everything that happened in that week's worth of traffic. You might think, okay, that's a great baseline. But what if there's certain processes that you only run monthly or every 3 months or every year? Okay, you need to be able to capture those particular segments as well to build up a full baseline. And until you've got that, a full understanding of what's normal in your network, it's very difficult to see what's anomalous. Now, I'm sure there would be people out there thinking, hang on a minute. So if I've got processes that I only run once a year, does that mean I have to gather data for a whole year? No, it doesn't. What it means is for say a month, you take your general traffic baseline, and then as you come up to these processes that occur every 3 months, every 6 months, every 12 months, then you would take a snapshot of the time before and after those particular processes to help you determine what the baseline is. So you don't literally have to take information for a whole 12 months, although you could choose to do that if you wanted to. It would just be quite an onerous and difficult job to do.
Okay, I think we can move on.
Okay, will do. All right. So real-time monitoring, being aware, that's what it's all about. Real-time monitoring is simply our way to determine what is happening on our system at this particular point in time. Now, as I said earlier, true real-time monitoring, instantaneous real-time monitoring is very, very, very difficult to achieve. There is always some sort of latency, particularly if you're obviously outsourcing your um, cybersecurity platform to someone else. There's always going to be some latency. So it really is near time. Unless you're physically connected via console or something to the device that's actually being attacked at the time, chances are you're not going to get perfect real-time analysis. So just be aware of that. Real-time monitoring, however, is still really useful because it keeps eyes on things. It's much better than saying, all right, once a week, I'm going to look at my logs to see what's going on. Much better than that. You could be a week into a cybersecurity attack, and by that stage, the attacker's gained a massive foothold. You're not going to get rid of them anytime soon. As it says in the second point, information returned is accurate only at the moment it was retrieved. So we also have to take that into consideration and understand that because of that point, we have to record everything. We have to keep it somewhere. We have to send it to what? A big data system. Send it to our data lake, our data warehouse, use our analytical tools to now look back on it and see what's going on while we're still doing this real-time monitoring. As it says there, this is a really important point. Traditionally, cybersecurity systems that we currently use for real-time monitoring often struggle to keep pace with how quickly things change in the threat landscape. So the evolution of attacks, the evolution of attack vectors. Every time you make a change to your system or potentially do an upgrade or a patch or an operating system patch or an application patch. Yes, you're patching something, but you're also potentially opening up another vulnerability. This has happened many times in history. It happens all the time. This, of course, is understandable when you think that commercial packages in particular, they're on a timeline, right? If they don't get if Microsoft, for example, only get an operating system out every 10 years, they're going to go broke. So they have to meet specific deadlines. Now, of course, while meeting those specific deadlines, there is no way possible for them to fully test their software or applications on every single possible combination of hardware and software out there in the world. It's just not possible. And so there's always a possibility that when new systems are released, when you buy a new platform or new application, that there are going to be vulnerabilities in it. There is absolutely no doubt about that. In addition, doesn't matter how good coding practices are, doesn't matter how good research and development is, doesn't matter how good testing processes are, there is always going to be something slipped through the net. There is always going to be residual risk. You can't eliminate everything. Big data, as I said, helps us to quickly respond to things when they happen because we've got this vast amount of information. We're logging everything. We're using machine language, AI to interpret it, spit out some answers for us, or at least give us some hypotheses, some pointers on which possible direction we could go. Big data analytics, and we've alluded to this already, immense potential. Okay, now it's true that bad actors, okay, the bad guys can also use big data to facilitate their attacks, to find new ways of attacking. So how does that work? So I'm talking about EDR, NDR, XDR, MDR, whatever systems managed detection and response systems, where we have agents installed on our desktops and we send that information out, and that's put into a big data repository. And that repository is searched and manipulated and interrogated via machine language and AI. And it comes up and it tells us what's going on and alerts us to things and allows us to respond to them in an agile way. But how does that work from the attacker's perspective? Our agents don't send log messages to attackers, surely. Of course they don't. But they bring in data through reconnaissance. So they'll go out and they'll look at open source intelligent repositories, for example. They'll look at, they'll scan systems, they'll identify potential targets, and they will use vulnerability scanning and penetration testing without really knocking down the door and breaking in to gather information. They'll find out as much information as they can about a target organization from any source possible. Guess where that goes? Into a big data repository that they can then use to analyze, interrogate, find out who are the most likely targets, who are the people or the systems that we are most likely going to be successful on should we launch our attacks. So it can work both ways. Oh no, here's this. Here it is. It was this week we were talking about it. I alluded to this before. I thought it was, there you go. I'm getting ahead of myself as normal. So this is the point I was talking about before. So threat detection, obviously we've already talked about that in the earlier section. In this particular report, 2023 IBM Security Cost of Data Breach, it states that on average, oh, so it was close, 203 days to detect data breaches. So remember, as I said before, this is an average of all the people that responded to the survey. So there may have been, I don't know how many companies, I can't remember. I have looked at the report, but I can't remember how many companies there were. But they would have surveyed a lot more, because rarely do you get, well, I've never done a survey or been involved in a survey where you get 100% response rate, or do you get 100% honesty in that? Some companies don't like to report that they've been compromised for obvious reasons around those intangible assets like goodwill and customer faith. So of the respondents who reported particular data breaches, on average, it took 203 days to detect that someone was even in their system or had been in their system and breached their data. 203 days. That's staggering. That's in round figures around 6.5, 7 months. And then once identified, once they knew someone was inside their system, it took them an additional 70 days to either get rid of them or to contain the problems that were caused by that attack. So that's 273 days. That's a massive chunk of a year. Massive chunk of the year. And think about the cost involved in that, not just in terms of the data resources that have been exposed or compromised, but the man hours, the technical response time, all the meetings that would no doubt go on, all the telephone calls backwards and forwards between people, all the stress and the strain on your workforce that causes. It's a massive impact. We can't just think about the cost of the data itself. We have to look at all those other residual costs as well, because they add up to a very significant amount. And so if we can leverage our data analytics through big data, and we can take a zero trust approach to breach detection. So that is, we basically trust nothing. By default, we trust nothing that comes into our network. We examine everything, we question everything. This can make a really big difference in allowing us to detect early detection of threats and respond in a more agile fashion when breaches do occur. It's inevitable that they will occur at some stage if you're a big target. And this allows us to respond a lot more quickly than we otherwise would have, because of this volume of data that we're now able to sift through in an efficient manner. Data analytics analyze patterns, detect anomalies that might signal unauthorized access. Again, tie that back to baseline, right? We need an adequate baseline, a well understood and verified baseline. We then compare that against the output from the data analytics from our analysis of our big data. we can potentially see what's going on. It allows us to, sometimes it allows us to say, oh, that's an attack. Let's do something about it. Other times it might be, that looks a little bit suspicious. I should investigate it further, and everything in between. We can also look at historical data and stuff that's happening right now, because we've got a big data system. We've got all this stuff that we've been logging to it for ever and a day, however long we've been doing it for. We've got all that historical data to go through. So that means that what happens if we get attacked in 2020? Something happened in 2020. We've forgotten all about it now. It's now 4 years later. Don't worry about it. But all of a sudden, something starts to happen and we think, wow, that's kind of familiar. We might never, just as humans, we might never even really go back to that 2020 attack. Big data analytics allows us to do that quickly and easily. It'll say, hey, this attack that's going on now, this is exactly the same behavior we saw back in 2020. What's going on? Go and have a look at it, investigate further. So it allows us to do this very, very quickly. We've got really good analysis of a thorough database. It's done very efficiently, very quickly, and allows us to remain agile in our response. It also allows us to predict attacks. So let's say, for example, we know that the last time we had a data breach, immediately in the weeks before it, leading up to it, we had certain patterns of scanning going on and certain attempts at remote authentication, for example. Okay, and now all of a sudden, 2 or 3 years later, we're seeing that exact pattern of behavior happening again. Big data can help us to say, hey, there could be an attack coming very shortly, like happened a way back. So it learns. Okay, and does it really learn? No, of course it doesn't. It just gets the algorithms, the machine learning, the systems get better at searching for these things and putting the pieces together based on this pattern recognition. Will it become more intelligent? I have no doubt that it will. Will it be like Cyberdyne systems from the Terminator movies? I don't know. Hopefully it'll never get that far, but it will get better at doing exactly what we're talking about here. Analyzing, providing us with the opportunity to detect and respond to attacks before they become really serious. And when you think about how much money that will save globally in recovery costs and incident response costs, you know, the benefits are obvious. Benefits are obvious. Analysis and identification of trends and patterns allows us to better identify our vulnerabilities on top of what we would do with vulnerability scanning and penetration testing, which we should all be doing in our digital systems anyway, as a matter of course, routinely, at least bi-yearly, sometimes more often, depending on whether you have legislation and regulatory requirements. It allows us to allocate resources more effectively. Okay, so if we can make predictions about what might be happening or what attacks might be coming in the near future based on what we know in the past, then we can say, all right, let's allocate some time, money, and effort to fixing that particular problem or the new problem before it becomes a serious problem and someone's in our system. Which then leads on to the last point, allows us as cybersecurity pros to convince management, which is always a difficult thing, to prioritize the different initiatives that we have in mind to help us to implement security strategies and mitigation techniques that helps us to ultimately drive our risk down as low as it can possibly get. There is always going to be some residual risk. No system is 100% secure from everyone. There's always someone who will find a way in. But what idea is, as cybersecurity people, is to drive that risk as low as we can possibly get. Zero is ideal, but unrealistic. But you can get it pretty low. Okay, so response can also improve the way our organization responds to attacks. Makes sense, doesn't it? We've got all this data that we're analyzing and going through with our machine learning and our AI, And it's telling us, okay, I'm pretty sure it's allowing us to narrow down what sort of attacks we might be looking at and how that might eventuate, how it might evolve in our system, which then allows us to respond in a more efficient and direct manner towards that particular type of attack, rather than just thinking, well, we've got a cybersecurity attack, we know that, but how it's getting in and what it's doing, we don't really know. So we're just going to put a whole heap of things in place and hope that one of them works. This helps you, big data analytics helps you to drill down closer to the root cause. So it does the root cause analysis much quicker and more accurately, and allows you to respond in a more agile and efficient way. This then means that the damage that occurs to your system when something goes wrong is going to be less than what it otherwise would be. So then your recovery costs, your recovery time, your recovery point objectives can all be met. And of course, we've got the forensic side of it, so the analysis. So providing us with evidence to show a chronological timeline. We can see what's been attacked, from where, by whom, and how. So it allows us to build it afterwards. Often at the time of a big incident, we're too busy trying to put out fires to worry about how they got into the system in the first place or what tools they specifically used. But afterwards, it's important to know that because it helps to inform us how we can better protect our systems in the long run and into the future, and to hopefully prevent these sorts, a similar sort of attack from ever happening again. So forensics is a really big and important part of it. Because we have vast amounts of data and we have these clever machine learning AI systems, we have the ability now to draw early conclusions and make predictions about what might be happening. So it allows us to be more proactive in cybersecurity, which is something that, as I said earlier this evening, that cybersecurity hasn't always been proactive. It's often reactive. So instead of reacting to things after they've happened or as they're happening, we can hopefully cut them off before they begin to take full effect. And big data makes that possible because it analyzes vast amounts of data and it enables us to detect potential threats in a timely and efficient manner than it would otherwise be possible with using any other method you can pretty much think of, really. And if we combine that real-time monitoring with the fact that we can also do historical data analysis, then it improves our cybersecurity defense mechanisms significantly. So let's have a look at some quick case studies, and then we'll sort of be finished for the evening, and we can sort of finish off with some questions and get out of here at a reasonable sort of time. So this one, the Ministry of Energy from Israel, they used big data to create a baseline of user behavior, which then allowed them to spot anomalies. These guys are an operational technology environment. Okay, so it means they're always active, always on critical infrastructure. And they always have to be available, obviously, because they're an energy provider. If they go down, the whole country goes down, so to speak. So their challenges were around the length of time that software systems were used, often used for 5 or more years, without any easy way to patch them or upgrade them. That sounds like a recipe for disaster, doesn't it? In addition to that, their software was often deployed in environments where typical enterprise IT security couldn't be applied because of the fact that we're talking about an energy system, so an electrical grid supply system. Of course, as with any type of organization of this type, they're going to have, or they had, a variety of technology, from cutting edge stuff to some legacy stuff that probably should have been phased out years ago. I don't know for certain, but I'd probably be pretty confident that that would have been the case. And in the past, their security people would have to manually analyze user activity on their system to detect the presence of anomalies. How long is that going to take? Okay, so it's always going to be retrospective. Any actions they take is going to be retrospective. So using a big data system, it was impossible, and I'm talking about this one was Splunk. In fact, all of these case studies are Splunk, if I'm honest. It was possible for them to automate the detection of those anomalies and therefore increase the efficiency of their and the timeliness of their responses. Another one, Lockheed Martin, so aviation company. And they use big data to develop a customized risk scoring framework for identifying, interestingly enough, insider threats. So internal threat actors and vectors. And the process that they came up with that came out of this particular framework was they decided that they would centralize and normalize their data, which we spoke about last week. And they use correlation and atomic searches to extract high value information. So they're looking at, building relationships between the data that they had. They then basically formed a summary of this particular information and then, which then allowed it to be more easily and efficiently processed at a later time. So instead of having to sift through everything again, they basically looked at it. All right, how can we normalize this data so it all looks very similar? We build relationships between the data and then we summarize it using our big data analytics to help provide us with quick and easy indexes, if you like, as I've said there, to be able to pinpoint it potentially or identify insider threats. Then we've got this word again. They built baselines on top of this data using machine language techniques. They fed detections from the baselines into the risk score framework, which were then used to alert when things went over a certain threshold and allowed them to then also do what's known as this security analyst triage. So in other words, looking at things popping up on your screen and determining what's more important than the other. So what's a real threat, what might not be a threat. If these two things are threats, which one is more important than the other? So going through that triage process, which then allows you to respond effectively and in kind to whichever threats are more important than others. Siemens, so electronic company. Well, they do a lot of things, but they're involved in electronics, electronic devices. Again, Splunk. They developed some machine-based security detections to augment their security operations center. So they already had a lot of security infrastructure in place and they had their own security operations center. So they help big data. They use big data to help build up their means and methods for looking at security detections. They performed baselining of proxy communications to then enable them to to identify when things were outside of what they would normally expect, allowing them to detect potential malware communications, in particular through HTTP and tunneling of SSH traffic, both of which are things that traditional IDS and firewall can't really detect correctly because it's encrypted. They identified 8 features from their proxy logs, including some of these ones here. And for each of these 8 features, they use machine language to train a baseline, to create a baseline that was expected for each one of these features. And then from that baseline, they were able to detect any outliers and therefore rank those particular outliers using an anomaly score. And guess what? When the score got too high, reached past a certain threshold, let's do something about it. Which is this part here, quickly triage potential malicious web proxy traffic. So we've got a set of features that we're going to look at. We're going to baseline. We're going to understand what looks regular normally. And then we're going to use those features to build that known baseline. When things fall outside that baseline, we're going to give it a score. Depending on that score, we'll determine when we do our security triage, which potential threats are going to be proactively looked at first. Okay, so it gives you, again, an order of precedence, an order of importance, a ranking of importance on what's currently going on in your system in a near-time capability. Some tools and techniques, last section for big data cybersecurity analytics. I know I've gone a little bit over tonight. I apologize for that, but this is some interesting stuff. So now we're looking at the specific tools that might be used. Now, I'm not going to go into huge amounts of details of these. These are outside the scope of big data, but basically what we're looking at here is the tools that we are typically implemented in cybersecurity platforms, which will then provide information to our big data systems for us to build all of the different detection and searching and anomaly detection and baseline capabilities that we've talked about this evening. So we've got our SIEM systems, Security Information and Event Management. They collect and analyze lots of different data from lots of different sources in real time. We can poke that off to a big data system, interrogate it using machine language and AI potentially. We've got, that's where it fits into our big data. It provides it with that information. Network traffic analysis tools. Okay, now they could be from things like Wireshark, which is a pretty popular everyday packet analyzer, or it could be other more commercially available network traffic analyzers, things like net flow counters, those sorts of things. SolarWinds is another example that's there. All of that feeds back into our big data system. We've got our intrusion detection and prevention systems. Again, they take on a lot of different information. They log a lot of different sources of information. If we think about that, we have network IDPS and we have host IDPS. Both of those can take a whole heap of logs and they can push them off to a big data system. So instead of just having a front end that looks at just IDP systems, we now put that into a big data system and we can compare it with all the other information sources that we have as well. So it provides a more rounded, in-depth analysis of what's going on. The big data platforms as well, which of course are involved, are the ones that we've talked about in previous weeks. So Hadoop, Spark, so on and so forth. Threat intelligence platforms, again, these are platforms that allow us to collect, aggregate, and analyze all of the different data from these system inputs that is related to threats, known threats or potential threats, either based on our own context or based on industry context. Then, of course, we have our machine learning and AI tools, which add that ability to learn more about what is going on in our systems and allows us to deep dive more into it, ask more intelligent questions, and get more intelligent outputs to help drive the way in which we respond. Data mining and packet recognition. Okay, fairly obvious what we're sort of doing there. We're looking for different types of correlations, corroborating evidence within these massive data sets that we've got. Anomaly detection, we've already spoken about. Okay, so looking for deviations from our normal baseline behavior above and beyond a certain threshold, whatever threshold we determine. Correlation analysis. So examining relationships between different sets of logs or different sets of data to see if we can build a bit more of a story about what's going on. Predictive, we know we can do predictive stuff now, predictive analytics. So by looking at what's happened in the past before big attacks, if we see that again, it enables us to predict what might be happening in the very near future. We can use NLP, natural language processing, which many AI engines do now. So it allows us to just search through unstructured data, things like text logs, social media posts, to try and pull out relevant information that might be related to attacks on our particular systems. And then, of course, the last one, I think it's the last one, yep, is the behavioral analytics. So understanding the behavior of users or systems that is normal, again, compared to a baseline in order to be able to detect anomalies. So as you can see, there's lots of different ways of doing it. Now, you might have a big data system that uses all of these tools and techniques, or you might have combinations of them. They don't necessarily all exist in the one system. You can imagine that would be pretty expensive. It would be pretty complex to develop, implement, and manage. But these are some of the tools you can use. I think the main theme throughout all of this has been the importance of baseline, so importance of understanding what's normal in your network or your systems before you can detect accurately what's abnormal. And the fact that big data gives us massive advantages in terms of speed of processing, depths of processing, and being able to potentially predictively analyze what's going on in our systems at any one time. So it allows us to respond more intelligently, so more directly to a specific threat, and allows us to do that in a very agile manner. All right, what other questions have we got, Shane, that I might hopefully be able to answer?
There's a few here. Uh, with these case studies, are any of the companies that are in them using automation to compare the real-time host-based detection against the data analysis alerts where anomalies are detected, or are they relying solely upon the analysts to compare both sources of detection and the alert?
That I can't answer. It wasn't actually mentioned in the resource that I was looking at that case studies, because the case studies were very much related to the advantages of big data. So look, if you take the case studies at face value, it's not verifying what is manually done, but basically using them as a source of automation. But whether that is 100% true or not, because remember, as I said before, all of these cases, or I think all but one of them was to do with Splunk. So you can imagine that there might be a bit of poetic license involved in terms of hyping up their product, if that makes sense.
Yeah. And also, I'd imagine that companies are a bit loath to give away too much data about how they got, how they fend off attackers, shall we say.
I would think so, yeah, because that then makes it more likely that someone will know how to attack them better next time.
Yeah. Tammy asks, I think there's an assumption that threat actors are actively doing stuff when they're in your systems. Is that always the case, or are they lying dormant, like, Russian sleeper agents, and which is why they're harder to detect?
Oh, that's absolutely 100% correct, Tammy. They are not always active in your systems as well. In fact, um, this is part of the reason why it can take a very long time to detect data breaches in the first place, because often, if they're serious, I mean, it depends on what their goal is. If it's someone that's just trying to deface your website, for example, then that's going to be pretty obvious right from the start. But if it's someone that's trying to gain a foothold into your system to stay there long term to spy on you, or to potentially see what's going on over a long period of time to maybe steal some intellectual property or some intellectual knowledge, then it's quite likely that they will act, that once they get into your system, they will simply hang around for a while, uh, upwards of you. I mean, I've heard of companies finding out about detecting people that have been present in their systems for upwards of 4 to 5 years without them knowing that they're there. So it's a very good point, Tammy, that not everyone is always active. And in fact, it's often thought too that when attackers get into your system, the first thing they will do is give themselves God mode or God access to whatever systems you've got so they can do whatever ever they like. That's often not the case. Often they will get into your system at a low level and just, slowly work their way around over a period of many months, because it's less likely to draw attention than it would be if someone broke into a system, then automatically created a new account and then elevated their privileges. So it's a good point, Tommy, and you're 100% right.
Do they, in that circumstance, once they're in there, do they become part of the baseline at some point?
It depends on, well, they could well do. It depends on how often you update your baseline, but that is another excellent point. So, obviously, a baseline, if you look at, even if you were to do a baseline over a period of 12 months, it may only be accurate for that particular period of time. And when you think about how often systems change, for example, or if you implement a new product, or you implement a new user-based system, or what happens if you take over another company or you yourself are taken over and IT systems change? What if you decide that you're going to implement a research and development area within your business? And so, or you're suddenly going to take on a new line of business. All of those things and a myriad of other things can then change the type of traffic that's going over your network, which means you need to refresh your baseline anytime something significant happens on your systems or on your network. And of course, as Shane just said, as you just correctly said, if someone's come in nice and quietly and they suddenly become part of the new baseline, they then become harder to detect. Absolutely.
What sort of approaches would we use to, correct or refresh the baseline data, or particularly if we think there might be something in there?
Well, if you think there might be if you don't know whether there's something in there, so if you're just refreshing a baseline, you go through the same processes as you did to create the baseline in the first place. So nothing changes. It's still the same process. But you have to have um, a very high degree of confidence that things haven't been compromised. Now, if you think something has been compromised, then you would use appropriate tools based on what you think might have happened and when you think it might have happened. Or alternatively, you employ an external consultant to come in and have a look for you. Um, if you have no idea that something happened, then or you're confident that nothing has happened, then the process doesn't change.
Okay. Most of the other questions here aren't really questions, or they're not possibly that pertinent. Somebody's asking, is there a single industry solution that provides both predictive analysis from big data repositories and real-time analysis from the baseline?
I'm not aware of any comprehensive solution that would do that. There are some vendors that might purport to be that, but when you scratch the surface, that's not the case.
Okay, we'll give everybody about 1 more minute to get any last questions in. I'm aware that we've gone quite late tonight. It's now nearly 9 o'clock Australian time. We normally try to finish. I will note that Catherine said that she'd read a book that said that some of the Russian cyber attacks take 16 seconds or a bank network 45 seconds. So, way too fast for any manual response.
Yep, absolutely. That is true. Some attacks do, yeah. And I mean, like even if you look at, say, CrowdStrike, right? They have a particular guarantee, and I can't remember the numbers off the top of my head, but it's something along the lines of that they will detect any attack within, I don't know, it's extraordinary numbers anyway. It might be they guarantee they'll detect any attack within 5 minutes, respond within maybe 20 minutes or something, and then remediate within 4 hours. So remove within 4 hours. So extraordinary sort of figures. Um, but they admit that there are in particular, two state-sponsored threat actors, one from Russia and one for China, that they have a lot of trouble getting rid of, and sometimes they can't get rid of them in specific cases. But these particular threat actors are looking at very high-level government type targets. So yeah, it's sometimes you can't beat them,
Yeah.
is what I guess it's saying. Yeah.
Does doing a baseline refresh impact change management?
Does it impact change management?
So is it part of the change management process to do a baseline refresh?
Oh,
Would
well,
you?
yeah, well, yes, if that's what the question is, then yes, it would, yes, absolutely. It would be part of the change management process. In terms of does it impact change management? It does it would in as much as your baseline changes uh, or evolves over time, then it might impact the way in which you implement or record some changes, yes.
Okay, we're really down to the wire now, and one of the questions that did come up, by the way, is just something for you to have a look at, Matt, which is that the document from IEEE is behind a paywall. That's in I think it's in the study guide for the second session.
Oh, is it?
Yeah, it's an IEEE thing. If you've got, I think because you might have an academic login, it probably wasn't for you.
Ah, right. Okay. Well, that's all right. Yes, I can access it otherwise and pop that up.
Great. I'd also like to remind everybody or to let everybody know that there is a survey goes out this week, and it's a good opportunity to give us some feedback about how the course is going and also to nominate any future course topic areas that you might be interested in. For example, this week we're doing sorry, not this week, in about 2 weeks' time, we're doing a 1 hour session just on how does AI lie and how can we find out why it lies and what goes on with that. So I'd like to point those things out to you. For anybody that's interested in more of our courses and more of our information, Lil will be putting up some things into the chat as well. But overall, I think, thank you very much, Matt. That was a big session, and I'm looking forward to the final week next week. Thanks very much, Lil, for looking after everybody in the chat, and we look forward to seeing you soon.
Oh, yeah, and just quickly, thank you very much, Shane, for your excellent emceeing job as ever. Thank you, everyone, for your attendance tonight. Next week, we'll look at the challenges around the big V's of big data, and then we'll be all done. So appreciate you taking the time to log in and listen. So we'll see you all next week. Thank you.
Great. Thanks very much, everybody. No, no.